welcome back to my channel. Today we are going to be studying the second chapter of Biology 5090 O-Level second variant of Caie. Let's start off by, if you have any questions you can ask me in the comment section below, or you can even DM me, which I'm going to link my Instagram afterwards. What are enzymes? Enzymes work as catalysts. Catalysts are the substance which increase the speed of a chemical reaction with no effect on themselves, like the chemical reaction does not affect them. Enzymes are made up of unique chains of amino acids. So hundreds and thousands of amino acids get together in order to form a single enzyme. Enzymes are present inside the cell and they carry out the metabolic reaction from there. Metabolic reaction is the energy formation reaction. So there are all different kinds of enzymes for different nutrients, and they all differ from each other. So their active site is basically different. So this is basically an active site of an enzyme. This is an enzyme, this is the substrate. Substrate is a nutrient which the enzyme will act upon, and active site is the point in the enzyme where the enzyme and the substrate fix like a puzzle, and this is where the reaction takes place. Example of enzyme is amylase, which turns starch into maltose, maltase, which turns maltose into glucose, and then we have lipase, which turns fats into fatty acids and glycerol, protease, which turns protein into amino acids, and then we have this picture which shows us how the enzyme works. I took the example of an amylase. This is how actually this is not the perfect, nobody really knows how enzyme really works. This is just a thought upon it. So this is an amylase, and the starch has fitted into it, fitted into the amylase. Now the reaction is taking place. So amylase has turned starch into two molecules of maltose. And so many people say that the enzyme and substrate relationship is similar to the lock and key theory. So in this phenomena, enzyme is the key and substrate is the lock. The key and the lock should fit with each other in order to unlock. Same is the case with the enzyme. The substrate and the active site of the enzyme should match with each other. Types of enzymes are catabolic enzymes and anabolic enzymes. These two together make the metabolic enzymes. So catabolic means breaker, which converts bigger molecules into simpler ones, while anabolic is builder enzymes, which turns excess amount of simple molecules into a complex form for storage purposes, but it does not convert it into its original form, as that cannot be done. So some examples of different types of enzymes are: for catabolic reaction, which is breaker enzymes, it is lipase, which turns fats into fatty acids and glycerol. For anabolic reaction, which means builder enzymes, it is glucophosphorylase, which turns glucose into glycogen. Moving on to the factors affecting the rate of activity of enzymes. Don't think that nothing can affect the enzyme. It can. And there are two things, which are temperature and pH. And in the case of enzymes, these two work similarly. They have three things, which are the slow activity, the optimum activity, and denatured. So let's start off with temperature. We have this graph over here. It shows the activity of enzyme. Optimum means maximum, and optimum temperature for plant where it would work the best is 35 to 37 degrees Celsius. For optimum temperature for animals, it is 35 degree to 40 degrees Celsius, and even 1 degree above can make the enzyme go denatured, meaning dead. So as you guys can see over here, from 0 till 30 we have a increasement of the activity, but not at the optimum point. Over here between 30 and 40 there's a curve forming. If the temperature would stay the same between 30 and 40, then it would be stable, but it's not, because the temperature has increased, and now as you guys can see there's a big steep slope over here, which means the enzyme is denatured and it has loosened its activity. It becomes, actually the active site loses its shape, so that's how it becomes denatured, and it does not work on the same thing, or actually does not work. So moving on to pH, which is power of hydrogen. Power of hydrogen means the amount of hydrogen in the atmosphere. So there's a whole scale about it. The scale is from 0 till 14, and from 0 till 6 it means it has the acidic nature, meaning very strong hydrogen. On 7 it's neutral, and from 8 till 14 it is basic, meaning very basic alkaline. So over from 0 to 3 it is very acidic, and from 12 to 14 it's very basic. So moving on to its effect on the activity of enzyme. This graph is similar. So pepsin is an enzyme which works on the protein, and this is how it is. And over here the pepsin's nature is acidic too over here. So what happens is from 0 till 2 the activity is increasing, it is low activity. On 2 it is maximum, but when the pH increases the enzyme becomes denatured, because the nature of its nature has already been gone, and so the enzyme cannot really work. Guys, it was a very small chapter. It's very easy, very basic. So if you guys understood the chapter, thank you very much for watching, and if you have any queries, comment down below. Please like, share, and subscribe to my channel. And my Instagram is makeiteasy4. Please follow me there. I post different things every day, tips, tricks, hacks about making studying fun and lessening the burden too. I post daily story about motivational quotes by me. So follow my account there as well. Stay happy, stay healthy, and love yourself.